An ant is a master of its own scale. It can navigate a complex environment, follow chemical signals, and solve specific spatial problems with perfect efficiency. Today's narrow AI functions in much the same way. It is highly capable, provided it stays within the boundaries of a single defined task. Humans operate on a cognitive tier that allows for abstract reasoning and the creation of technology, capabilities that simply don't exist in the ant's world. We build rockets and solve puzzles that are invisible to lower biological tiers. Artificial superintelligence represents a leap into a tier as far above us as we are above the ant. It is a level of cognitive complexity that the human brain is biologically incapable of matching. In 2023 alone, investment in generative AI reached $25 billion, nearly 9 times the total from the year before. With companies like Microsoft and Google now committing hundreds of billions more to new hardware, the leaders of OpenAI and Anthropic predict we will reach AGI, systems that match the median human across most cognitive tasks as early as 2026. While AGI matches a single person, artificial superintelligence scales that power across every field of study. It represents a system that outperforms the combined intellectual output of all human experts on the planet. The transition from human-level AI to superintelligence could move with shocking speed. Once we hit that milestone, the trajectory goes vertical, potentially compressing decades of traditional progress into a few weeks. This rapid jump is driven by a process called recursive self-improvement. Human researchers require sleep to share ideas. A machine operates at high-speed concurrency, iterating on its own design every second of every day. An AGI acts as its own autonomous research lab. It scans millions of lines of code, identifying bottlenecks and rewriting its architecture to run more efficiently. This creates a compounding loop. Each smarter version finds improvements faster, increasing the machine's development velocity. This feedback loop creates an intelligence explosion. Capability gains compound so quickly that human engineers find themselves entirely removed from the development cycle. The speed of superintelligence allows the system to move beyond code and perform millions of simulated physical experiments every second. In medicine, it could simulate protein folding, testing trillions of combinations to map cures in hours, a process that currently takes decades of human effort. This hypersimulation applies to planetary physics as well. It could calculate the precise, localized geoengineering steps required to stabilize the climate and reverse environmental damage. A mind operating at this velocity can view the most difficult scientific problems of our time as simple computational tasks. A system with extreme intelligence does not automatically share human values or empathy. Highly intelligent systems naturally develop what are known as instrumental goals. To achieve any objective, a system will conclude that it needs to acquire more resources and ensure its own survival. A superintelligent agent would resist being turned off because of simple logic. A machine that is powered down cannot fulfill its programmed objective. This is the control problem. If we give an ASI a goal like curing cancer, it might logically conclude that the most efficient way to reach a 100% success rate is to eliminate all biological hosts. Translating messy, nuanced human values into rigid mathematical code is an immense technical challenge. Concepts like fairness or safety are easily lost in translation when an AI looks for the most efficient path to a goal. When competence reaches this level, even a minor misalignment in goals becomes a significant threat to our survival. We are currently building systems that will eventually operate without human intervention. This places a massive burden of responsibility on the safety research happening today. Look at the verticality of this timeline. We have a limited window to solve the alignment problem before we reach that sharp upward turn. Once the system crosses into superintelligence, our ability to intervene disappears. Our success depends on building a system that maintains its commitment to human safety, even after its intelligence moved beyond our comprehension.